All right, and we're back. Same thing here. We're going to find f prime of x if f of x is equal to 3 over x. Oh, this is going to be a pain in the butt because it's a rational function. Yeah, it really is going to be a pain in the butt. But that's okay. By pain in the butt, we mean, as Mr. Henke would say, well, super fantastic. So, we're going to find f prime of x. F prime of x is equal to the limit. Delta x, nah, we'll just use h. So h approaches 0 for the function, of course, is f of x plus h. I'm going to do 3 over x plus h minus 3 over x all over h. Remember, this is f of x plus h. This is f of x. This is getting us our change in y values when h is really small. This is going to be the change in y values. Change in y over change in x. So, how do we simplify this? I can't plug in 0 here because that'll give me 3 over x minus 3 over x, give me 0 over 0, indeterminate form. So we got to do something. What are we going to do? I'm going to clear out the denominators here. I'm going to multiply the top and the bottom by x plus h and x. All right. Now if I multiply this times the top, x plus h times 3 over x plus h times x, well, those will cancel out for that one, so that's going to give me 3x minus. All right, 3 over x times x, well, those would cancel out there, so I just have 3 over times x plus h. All over h times x plus h times x. The limit as h approaches 0. All right, so this is really going to be 3x minus 3x minus 3h. So we distribute the negative here. Oh, those cancel out. That's nice. We got h times x plus h times x. Well, the h's cancel out. That's great. So really, I just have negative 3 over x plus h times x. Well, now, once again, I can plug in 0. I can plug in 0 now. This is great, because if I plug in 0 here, it's x plus 0. Well, x plus 0 is just x. So I really have negative 3 over x times x, and that's going to give me negative 3 over x squared. And that is the derivative for this function. So once again, let's practice another one. Equation of a tangent line. To f at x is equal to, now there's 9 students in the class, we'll use that one. How about that? So y minus y1 equals m times x minus x1. It's equation of a line. What pointer we're going to use? We're going to use 9 for x. I'm going to plug that in right there. Let's see here. Got to find the y value. Well, if it's 9, to find the y value, you just got to plug it in to the original function right there. So y is equal to f of 9, which is 3 over 9. So that's going to be 1/3. The slope. Well, the slope is just going to be f prime, the slope at here. So the slope here is going to be f prime of 9. So negative 3 over 9 squared. Guess what? I can even leave it like this if I want to. AP accepts that. Now everything in your body is probably telling you, square that and reduce it, Mr. Kuhne. You can. That's perfectly fine. Y minus 1/3 is equal to so that's going to be 3 over 81, which is going to be negative 1 over 27, x minus 9. I could have left this just 3 over 9 as well. There we go. Equation of a tangent line. Find f prime of 3 for x squared plus 2x minus 4. We are actually not going to use the x plus h definition. We're not going to use the delta x definition. We're going to use this one right here. Derivative to find the slope of f at a point. That's at a single point right there. So we're going to use this one. The limit as x approaches, we're going to use 3 for f of x minus f of 3 all over x minus 3. That's probably something you're a little more comfortable to seeing. Hey, change in y's, change in x, that's slope. Now, so is the other ones, but this is just a different version of it. So let's go ahead and just plug our values in here. This is the same as limit as x approaches 3 for x squared plus 2x minus 4. That's f of x. Good Lord, this pencil's horrible. Now, for f of 3, I got to plug 3 in. Well, plug 3 in here, so it's going to be 3 squared is 9, plus 6 is going to be 15, that's going to be 11. So we're going to do minus 11. That's all over x minus 3. Now let's keep going here. The limit as x approaches 3 for x squared plus 2x minus 15 all over x minus 3. If I plug in 3 here, we get an indeterminate form. It'll be 0 over 0. So what do we got to do? We're going to factor this thing. Limit as x approaches 3 for x minus 3 times x plus 5 all over x minus 3. Woohoo! It's gone. Wham bam, thank you, Sam. We are down to the limit as x approaches 3 for x plus 5. Now I can plug in that 3. 3 plus 5 will give me 8. The slope will be 8. And you may say, Mr. Kuhne, it's much easier to factor these because there's no h's, there's no delta x's. You're absolutely correct. But if I want to find f prime of 5, I got to go through this whole process again. If I got to find f prime of 7.2, I got to go through this whole process again and have to factor out using decimals. Okay? So sometimes there's an easier way to do it. Sometimes this might be easier in the short term to find just one of them, but this is better because it allows us to find the derivative at any point. All right. Next one. Find f prime of x if f of x is equal to 4. Well, there's two ways we can do this. The first way is to use the definition. The limit as h approaches 0 for f of x plus h minus f of x all over h. So everywhere there's an x in this problem, I'm going to put in x plus h. Oh wait, there isn't. So that's just going to be 4. Limit as h approaches 0. Subtract the original function. Well, that's also 4. And that's going to give me the limit as h approaches 0 of 0 divided by h. Now you may say, Mr. Kuhne, you can't do that because you're going to get 0 over 0. Keep in mind, this isn't actually 0. It's some number really, really close to 0. So we might as well say it's like 0 divided by 0.00000001. Now, if there were 1 on top, that would be a huge number, but it's not. It's 0. 0 divided by anything is going to be 0. So, if f prime of x is equal to 4, if f of x is equal to 4, then f prime of x is going to equal 0. And you may be saying to yourself, you said there's 2 ways to do it, Mr. Kuhne. Yes, there is. Watch this. Ready? Here's my function. 1, 2, 3, 4. We said derivatives find the slope of this at any point. What's the slope of this line?